was from the Department of Physics. He won York's 3-minute thesis last year, 2019, and then went on to compete as one of 6 finalists in the 3-minute thesis finals organized by VTI, which loosely is considered like it is like the national finals, isn't it? It's actually international finals because they have international member institutions as well, but yes. So can you tell us a little bit about your research and where you are right now in your PhD?
Yeah, sure. So I'm in my final year, so I'm also in my write-up period. I think about 6 or 7 months left. So my research broadly, I'm in the area of fusion energy. So essentially harnessing the power of the sun and trying to find a way to do that on Earth. And there's lots of different strands of that. I'm in a particular strand that we call inertial confinement fusion. And there's, again, in that aspect, there's a few different ways of doing it. But essentially what you're trying to do is take some fuel and compress it to really high densities and really high temperatures. And the way that I look at doing that in my research is through using high power lasers. And so I call myself a laser plasma physicist, which essentially is taking really big laser systems and shooting them onto really small targets and trying to understand the physics of what goes on, or it happens there. So yeah, I get, so I'm involved in a bunch of different experiments. The main core of my PhD is focused on the fusion aspect of it and looking at essentially how X-rays are produced around these fusion capsules and how we use those X-rays to drive the compression. But among that, there's lots of different areas of other laser plasma research I'm in, and this involves mostly at the moment simulation work. So fortunately, I'm at a time in my PhD where I can just sit at home and log onto a computer somewhere else and do all my work from the desk. But I've done some experimental work as well before, mainly a facility down in Oxford, which was working with these huge laser systems.
Ooh, that sounds very high tech, and I would have real problems understanding it if not for how clear you talk about it. I think one of the reasons, so I was on the judging panel for the York 3MT last year, and like when you gave your 3-minute thesis, I was like, this guy gets 4 points from me because I understand every single concept that he's talked about. Yeah, so actually I wanted to ask you about that. Like, a lot of what you do is quite technical, involves a lot of science, like it's very sciencey, isn't it? Like there's really no way to get around that. So I wanted to ask you, how do you talk to the everyday person about, like, not just in a public engagement space, but how do you talk to family and friends? And I ask this because I think talking to people that are close to us or people that we meet in the pub actually is a really good starting point for starting to practice our public engagement, to be able to just explain it to like the man on the street. So how do you do that?
So I think like the main thing that you always do is just avoid jargon. I think Mickey was saying earlier that technical terms are just hard. So I said just now that I call myself a laser plasma physicist. Laser, fair enough, but in my 3MT, I didn't even use the word plasma because there's so much explanation that comes around how plasmas work. That's really the key behind my work. But yeah, just in general, avoiding jargon. I think this is the real challenge that I mainly had in my 3MT is there's so many different scientific concepts that you have to explain that you basically, you have to do it in a way that relates to what people already know. So mainly when I'm doing public engagement, I look for good analogies and experiences that other people can relate to. And I think it's key when I look at those to try and pick an analogy that sort of actually relates to the physics quite well. So one of the things I talked about in my 3MT was how one of the ways we drive compression is by using a can around the capsule, and we actually shine the lasers onto the cans. And then the can heats up and starts to act like an oven. And when I say it acts like an oven, that's not just, it's using people experience something they know already, but the physics of that heating is essentially an oven. The radiation that comes off from that is like like an oven, but just way hotter and coming off in a different form. So in that, I think it's important to find, aspects that people can understand, but also that are still correct. Because I think it's easy to give an explanation that relates to people, but doesn't actually quite get across the understanding. So I think, in terms of the science and explaining those concepts, that's what I generally do. But also there's loads of aspects around talking about my work that don't have anything to do with the actual technicalities. So I tend to focus, especially when I talk with my family, on, you can talk about your personal relationships and stuff as well. Scientists, even though you sit around expensive equipment and try and do clever stuff, you still have silly stories and stupid things that happen. And especially when you're on a 6-week long experiment, you end up playing tricks on each other, and like any normal person. So you can focus on telling those stories a lot more. And those are the sort of ones you tell down a pub as well. People you meet, the characters they get into, and they sort of like frame the research as well. And you can slip in like the cool facts of all the kit that you work with. So I always like to, when I'm on experiments, some of the equipment we work with is hundreds of thousands of pounds, and some of the shots we do on these systems are worth about $1 million. It's a US system that I've not worked with directly, but one shot on these experiments costs about $1 million just to do one day. So there's the other thing, you can cycle in your cool facts and have a little in the few things in the back of your head to bring up and try and impress people.
I think that would be exceptionally good for talking to school kids, like to try and get like younger people interested and excited about science, is when you get to tell them all these like cool mad scientist type stories of like cool lasers and cool equipment.
Yeah, it's cool.
Yeah.
Sorry.
So actually, on that note as well, I wanted to ask you if you could maybe share some advice for anyone who's thinking about applying for 3MT either this year or next. So maybe you could share a little bit about your own process of writing your application and how you prepared for the finals itself.
Yeah. So I think in general, the way I sort of came about structuring mine was to try and do, I think this works particularly for science, but I think there's a few different ways to approach it. For me, I tried to come with we call an hourglass structure, where you start with big picture stuff and you work down narrowly and get more specifically into what you did. One of the things that I really struggled with was talking about the actual stuff I did. So we talked a lot about the 3MT when we were going through the process. There was sort of like a anti-parallel between humanities and scientists, where scientists could do the big picture stuff really easily, saying, I work with fusion research. That's an easy concept to understand and why that's easy to get across. But then bringing that down into the technicalities of actually what I do is really hard to get across, because there's so many basic concepts that I have to explain. It's really difficult to get across, what my day-to-day is like. Whereas the humanities side, it's a bit more, maybe it's easier to talk about specifically what you do, what you're researching, but actually then it can be hard to get across the implications and the applications of your research. So yeah, I think my advice will mostly work for scientists, but this is why I sort of try to start with big picture and narrow it down, focus on a concept, as you go through, and eventually just get to the very small part of what you talk about. And then on the second half or second part of your talk, you sort of bring it back out to that application and talk about the wider aspects of your research again. And it brings me to one of the other bits of advice that I'd sort of say was, that's not quite what my talk was when I first started. So it changed a lot, especially in that first process. So the thing that I wrote, I don't think any of the sentences really translate into my final talk. And with all the support and stuff that you get from the uni, just be prepared to be open to change and get all the feedback. Especially listen to people. I think that's one of the values of the York 3MT process. We had so many people attending these training sessions we did from different areas. You get really valuable feedback from people who aren't familiar at all with your work. and you know, they can just say, I didn't understand that concept, get rid of that or explain that better. So yeah, be open to change. And then finally, just the probably fairly obvious one is just practice it, practice it, practice it. I think for the audition stage, a few times, my audition, actually, I didn't have it well rehearsed at all. I actually froze up for like 10 seconds in my audition because I forgot what I was saying, but I still managed to get through. But as you go through, you know, you get through the stages, you just got to keep practicing it, and find different ways to sort of make it hard for yourself. But just the more times you go over the 3 minutes, the better. Let's recheck my notes. I think, yeah, that's about all I've got with the time, cool. I think.
Yeah, a lot of what you said really resonated for me as well. Like just thinking back about on my experience 2 years ago. So sorry, I should have explained to participants earlier on that I was also a 3MT finalist in 2018. I won the competition at York and then went on to also compete at the national VTAI finals. I just wanted to pick up on two things that you'd said. So first of all, the memorizing it and then practicing it. I mean, it was literally like I would just be in the shower, like rehearsing it to myself. Every time I go to the toilet, I'd sit there and do it. Yeah, so I mean, it's only 3 minutes, so it's quite easy to do. But I also want to, in case anyone is applying for the 3MT, it doesn't need to be perfect for the audition, and your application doesn't have to be completely polished. It doesn't have to be, you know, like Will said, it's going to change many, many times before you do the actual final. In the application, it's more judges, I think, will be looking more for whether there is potential to be developed. So you don't have to worry about memorizing it perfectly or anything like that. Like, don't get stuck on those details. Just concentrate on putting together a good application with a good focus as to what you're trying to communicate. And the second thing I wanted to pick up on was, but being prepared to change your presentation. That includes changing possibly the slides that you use as well. And that was quite difficult for me because, you know, like you said, there's so many things that you want to communicate. Everything's important when you start, when you first start your 3MT. And I get very precious about things. You know, I want to put everything in because everything's important. And it's a real process of learning to completely hone what you're trying to say, and realizing that some things don't have to be in there, and being prepared to let some things go, and that's okay. You know, like it is only 3 minutes, so not expecting a full exposition on your methodology and everything. You will lose some things, and that's okay.